It is opening day of an exhibit, a most unusual exhibit, in a most unusual building. Here on display and at work will be the atom. Here also will be an example of cooperation. Cooperation among nations and among people. For the United States Atomic Energy Commission conducts this exhibit throughout Latin America with the cooperation of its host countries' scientific and educational communities. Its purpose? To demonstrate the objectives of our program, Atoms for Peace. The excitement of the event fills the air. There is music. And there are speeches. Speeches carrying the themes of friendship, progress, peace. Ribbons of national colors tied together hold back the eager audience until the final moment. The ribbon is cut. The exhibit, Atoms at Work, is open. But the excitement and glamour of opening day represents months of planning and hard work. The exhibit building had to be designed. A huge air-supported structure, the length of a football field. Its interior was planned to handle a large flow of visitors. Contracts had to be drawn for every phase of the work. The shipment of materials was planned well in advance, as was the printing of exhibit literature in the language of the host country. Also of great importance was the selection of a good site, one which would be convenient to many people and in attractive surroundings. The site has been chosen. The work begins. First phase is the laying of a concrete foundation. All materials going into the base have been purchased locally, and workmen from the area make up the labor force on the project. Tons of concrete are mixed and poured. Some of it goes into this wall, over 6 feet thick, which will act as shielding for a nuclear research and training reactor. An asphalt surface is spread and firmly pressed into a smooth, hard floor. The foundation completed, steel arches are erected at both ends, the building's only rigid supports. Under these will be fitted air-locked revolving doors, allowing the streams of visitors to enter and leave the exhibit without disturbing the inner pressure necessary to support it. With its base finished, the rest of the exhibit's home will rise in a matter of hours. 2 layers of vinyl-coated nylon, supported entirely by air, will form the building's walls and ceiling. The fabric sections are unfolded, spread over a huge area, 300 feet in length. The thousands of snaps which join the sections are fastened together, one by one. To connect the 2 layers of each section, huge zippers are drawn. The edges of the fabric are attached to contour pipes, which are bolted into the concrete foundation. All is ready. The building is about to be raised. It will be inflated by these giant blowers. The blowers are driven by the building's own generators, which also allow the entire exhibit to operate independently of the local power supply. The power is turned on. The blowers start. The giant shape begins to form. The air entering between the fabric layers will not only support a strong, safe structure, but act as insulation under its expansive surface. A constant pressure will be maintained inside the building also. One great enough to hold up the 54-foot ceiling, yet low enough to go unnoticed by the visitors inside. In only 30 minutes, the entire building is up. And now, while final preparations take place inside, a good scrubbing reveals her sparkling coat for opening day. Although everyone is intrigued by the huge white building, what they will see inside is far more impressive. Entering the first dome, visitors find themselves in a large theater. Here, projected on 3 adjacent screens, a unique film introduces them to the atom. Leaving the theater, the audience enters the exhibit area under the second dome. Organized in logical sequence are 5 demonstrations, each having its own lecturer, a university student or scientist trained to explain the display and answer any questions. First is power, the power of the atom and its never-ending stream of energy. How a reactor's nuclear energy is converted from heat to electricity is shown on an animated model. The audience moves next to the industry exhibit. Here, they learn how modern industry is using this new force. Radioactivity is shown as an effective tool in detecting flaws in materials, determining areas and amounts of wear, and in helping manufacturers control and improve the quality of their products. From industry to agriculture, once again, the visitors hear of the value of radioactive tracers, this time used to learn more about animal and plant life. With tracers, the best uses of feed and fertilizer can be more easily determined, and the nutrition of poultry and livestock more accurately studied. These colorful genetic changes were produced by controlled irradiation, a type of work which has led to the breeding of improved disease and weather-resistant crops, crops which will aid the world's food production. Pest control is another benefit of atomic radiation, as is the prolonged preservation of some foods. From plants and animals to human beings. Here, in the medical exhibit, the atom's contribution to biology and medicine is seen. A life-size plastic model simulating the human body, its fluids and organs, is used to demonstrate tracer uptake and radiation therapy. Here, one sees how isotopes are employed in the diagnosis of various diseases, such as cancer of the thyroid. As in the handling of all other forms of energy, certain precautions are taken in working with nuclear energy. Mechanical hands offer a most intriguing demonstration of how safely and accurately radioactive materials can be handled at a distance. Never a drop spilled. And even a drop at a time. Having seen the atom on display, the audience can now witness it at work. For the remaining exhibits are not merely models, but working facilities being put to good use. This is the gamma tank, with its radioactive cobalt safely submerged under 10 feet of water. Materials from all over the host country are sent here for experimental irradiation, This valuable research and training tool affords some scientists and students of the host country their very first opportunity to work with such equipment. Visible to touring groups, but housed under its own plastic dome, is the nuclear reactor. In the comparative privacy of the air-supported bubble, seminars are given on the operation and uses of the 10-kilowatt reactor. During the stay of the exhibit, it will actually produce short-lived radioactive isotopes for use by medical and educational institutions. Engineers and scientists study all phases of this powerful yet sensitive instrument and are able to conduct experiments in reactor physics. And while this challenging work is going on, additional instruction is taking place behind the scenes. This room is filled with high school students and their teachers, all anxious to increase their scientific knowledge. They learn of many things. Some of the principles of elementary physics, and some of the fundamentals of nuclear physics. The courses for high school students are patterned after the Science Demonstration Lecture Program developed by the Oak Ridge Institute of Nuclear Studies. For students of professional status, there are advanced seminars conducted by U.S. staff scientists. Visiting scientists, engineers, and teachers can also take advantage of a technical information center. Available in these pleasant surroundings is a wealth of information on nuclear energy. A wide variety of scientific and technical publications, as well as a film library complete with projection facilities. U.S. staff members will gladly assist visitors in finding the solution to some technical problem or merely in satisfying some scientific curiosity. This, then, is Atoms at Work. Through it, the people of Latin America will see some of the many uses of the atom, uses of great benefit to them and to us. For the United States Atomic Energy Commission presents these exhibits, this instruction, and this information to our neighbors south of our borders as a cooperative expression of friendship. It is part of the Atoms for Peace program we shall continue to pursue, to inform the peoples of the free world of the beneficial uses of atomic energy, to provide opportunity for person-to-person contact and a free exchange of information between nuclear scientists of all nations, and most of all, to demonstrate our desire to cooperate with men of goodwill everywhere in building a better world, one in which we can all more fully enjoy the blessings of freedom and peace. To these ends, we have Atoms at Work.